Oh, hey, welcome back everyone. Thanks for watching the channel. I'm just scrolling through the Weld app here, killing some time, and I see my guy Caden Harper here. He asked for advice on this fillet weld. Looks like a simple fillet weld, 7018, all that good stuff. And it's got some good welds on there, but the size is a little funky. And I want to explain to you all that are going through weld school exactly why we do fillet welds the way we do it, where they're located, how they can look, what they look like as weld symbols, how we can control the outcome of the shape and size of these fillet welds. So let's get into that today. Now, before we get to burning any wire or rods, let's learn a little bit more about the theory. The first thing we're going to go over with the fillet welds is the joint configuration. We've got our T, our lap, and our corner joints. These are all the joints that you're going to see fillet welds on. Now, what do these all have in common is they all have a 90-degree where they come in, each member meets at some point kind of perpendicular to another. One line makes a 90-degree angle. So we put our welds right in those 90-degree angles on our T's, our laps, and our corners, whether they be the inside or the outside. These are going to be the way and where the welds go. Now, where they go on each joint is going to be up to the weld symbol. Luckily for us, the weld symbol for a fillet weld is the same shape of the weld we put on the actual metal. Now, where this ends up being, whether this symbol is on the bottom or the top of the line, actually matters. On the bottom is the same side that the arrow is pointing, whereas if it's on the top, you have your other side. And I always thought that was backwards, and that's actually how I remember it, is this is backwards to me. But regardless, if this arrow is pointing at this T joint and we have the symbol on the bottom side, that means we're going to put our weld on this side. And if that symbol is on the top, then we put it on the other side. And if it's on both, we'll put it on both sides. And if this happens to be a piece of pipe, or maybe it's longer and there's room to weld right here, it might have this here symbol that says weld all around, which means we'll weld all around this part in this fillet weld. Now, as far as weld size, we'll get into that now. So the next thing we'll talk about is our weld size. We know our joint configurations. Now what happens when we just toss a number in right here? To the left side of the weld symbol, we have our weld size. Now this is going to say from toe to toe, and remember this weld symbol's on the other side, so our weld's going to be on the other side. So from toe to toe, from this point to this point, that's going to be a 1/4 inch. That weld is going to be pretty much a 1/4 inch tall, but it's going to go out in both directions. So that's how we're going to make sure that we measure our size. Now, how big does a weld have to be? Well, say we have a 1-inch plate right here and we have a 1/2 inch plate right here. Well, we only need a 1/2 inch of weld to complete this. So maybe we put the 1, we put 2, maybe we even put 3 passes on there to make that 1/2 inch weld size, but we don't need to do the full 1 inch as far as the weld size, because the strongest part of the weld or the member or the joint configuration is only as strong as the thinnest member. So that's the size that we need to operate at. Now again, with this size getting bigger, say from a 1/4 inch, and then we move up to, let's call it 5/16. 5/16 of a weld, maybe now we have to put 2 passes on there in order to achieve that 5/16. And how we measure that is with a fillet weld gauge. Now as far as our pitch and length, we'll get into that a little bit later. Now, getting the desired fillet weld size that you're looking for takes a little bit of practice and takes some time of actually seeing it to understand how big you can actually make a weld. And this varies on a couple different reasons. Now, as far as filler wire, MIG and flux core, obviously the bigger wire, the bigger the weld, right? Same thing with stick rods. If we use a 332 rod, we're going to get a smaller weld than if we use a 1/8 rod. Now, this can also change as far as your travel speed. Your gun angle, push or pull, might make it a bigger or smaller weld, more humped up, and it's all just takes a little bit of practice to understand it. But you do need some fillet weld gauges so that you can measure each weld afterwards. And that's what we're going to be doing today. We're going to use this AHP Alpha MIG 231 to do some MIG and some stick, 6010, 7018, and make sure that we can measure each pass as a single pass and see how big it ends up getting with each one of these processes, as well as how big they get if we keep stacking welds on top of them. Now, this Alpha MIG 231 isn't the prettiest machine I've ever seen. Doesn't leave a lot to the eye to look at, but it is still a powerhouse and it's really easy to set up. We're gonna set up for stick first, and it's just 2 leads. plug in your stinger to the positive, plug in our ground to the negative, and we're ready to go. This is a great machine for beginners because the price point's only at 700 bucks for this puppy, and it does have a lot of power. 26 volts, 180 amps. You'll be able to get a 50% duty cycle whether you're running with MIG or you're running stick with different rods like 6010. It'll run spool gun, it'll run flux sport, it'll run stainless steel, it'll run all that good stuff with MIG, as well as your other rods that you can throw in there. Same thing with its hot start times, percentages, inductance, all that good stuff it has. And this is the machine that we're gonna use for today's demonstration as we go about doing these T-joints. They're 3/8 plate. We're gonna put a single pass with a 332 7018, a single pass with a 1/8 7018, a 1/8 6010, and do a little bit of MIG welding passes as well. We're gonna see how big each one of those fillet welds gets, as well as multi-pass welds and how each one stacks up and how big they get. So let's get into welding some stuff. So again, here's our project. We got each one of our T-joints set up with some 3/8 plate. They're all tagged together. We're gonna use 332, 1/8, 7018s for either one of these. We're gonna use some 6010s for this one, and we're gonna use some 70S6 MIG wire with 7525 mixed gas, and we'll be using these fillet weld gauges. We got a bunch of different ones. But these first ones are probably gonna end up being close to around this 1/4 inch size or this 5/16 size. So that's gonna be my guess for these first passes. That'll probably be a 1/4 inch, that'll probably be 5/16, that'll probably be a 1/4 inch, that'll probably be 5/16. Somewhere in that range is what we're shooting for. Before we dive into the results of these stick welds, and I've got some pretty interesting, results that came out of it. I'm excited to share, and I hope it helps this YouTube channel and everyone inside the Weld app. We're gonna go ahead and set this machine up for MIG. If you guys are doing your fillet weld journey, it's likely that y'all are pretty intro to the whole thing. So we're gonna make sure that you guys understand setting up a MIG machine and putting on a fillet weld and measuring about what size you're gonna get. And remember, it's a wire-fed process, so you're gonna be able to really control the amount of fillet weld size by either speeding up or slowing down, and you can get a wide range of sizes. Again, this Alpha MIG 231 is pretty easy to set up. We unplugged our stinger. We're gonna go ahead and plug our MIG gun in. Make sure that it's nice and secure and lines up with all the holes. Go ahead and run that. You might give it a little wiggle and a jiggle and push in and screw this nut on so it gets on there really nice and easy. Then we can toss our spool on. This will hold an 8-inch or a 12-inch spool, so it will hold the big boys. And it also runs wire sizes from 023 to 045. So again, it runs big spools, big wire, tiny wire, all that good stuff. Where the freak are my cutters? Let go and this is gonna bird nest. Make sure you got your spool on the right way and it's locked on with the nut in the back so that it rolls. And it does come with all the rollers that you need as far as for all those different wire sizes, and it does have a 4 drive roll system, so you know that it can really feed some inches per minute. About 600 is the one, I think, where it maxes out at. Once you got that locked in, you're good to go. And it comes with different tips. It comes with a regulator. It comes with everything that you need to get started to weld. Once that wire comes out the end of this Benzel 24 series MIG gun, then we can hit this test gas flow. We can hear the gas coming out. But don't forget to turn the test gas flow off because it will sit there and run the whole time. So we'll get it out there, set it to the auto pre and post flow, which is really nice. You can set it, does have it to where you can set it, but the auto set's pretty sweet. Let's set our settings for the voltage and wire feed speed. Still pretty intuitive to set everything up, real simple. We got our MIG gun plugged in here at the bottom. We've got our stinger undone, but we're running DC positive. Now, if you're gonna be doing some self-shielded flux, you're gonna wanna switch that polarity. But We're gonna set up for MIG right now. We can go into our volts, our spot time if we're worried about spot or stitch, which we'll get into. We got our burn back, which is the wire actually burn away from the weld back towards the contact tip. Now you can adjust this. This keeps that wire from sticking to your weld, but at these higher volts, we want to keep our burn back pretty low. So we're going to go down to burn back. We're going to set this down to about 0.1 or 0.2, and then the inductance is going to be the crispiness of our weld. The higher we go, the more fluid that puddle will be. So we're going to keep that inductance, being that we're welding some fillet welds, somewhere around 70% as far as the inductance goes. Now we got our wire feed speed over here, somewhere around 400, 380 or something, should match these volts pretty all right. And then again, as far as the stitch time, we can get into that a little bit later. Gas is all set up, ready to roll. We pulled that side, we'll go ahead and push this side. The trick to a push or pull is to just not favor too much of a pull or too much of a push, but you can get away with both. Before we get into the meat and potatoes of this video and start measuring fillet welds, there's still one more aspect of the basic fillet weld symbol that I want to touch on. Now back to the basic fillet weld symbol. Again, we have our T-joint, even have another plate here that's just kind of some scrap iron that I'm going to use as an example. So far, we've really gone over the size. So right here where this S would be, we would have our size. I would say maybe 1/4 inch. That's about one pass, depending on what rod we're using and travel speed and all that good stuff. At least we're going to be aiming for that 1/4 inch size weld. Now we have L and P, or length and pitch. Now this is going to really kind of determine if it's intermittent fillet welds. An intermittent fillet weld is where we actually space out the welds and put little stitch welds or spot welds. Kind of what this machine over here is capable of. And the reason why there's a stitch and a spot timer on it is so that we can accomplish these intermittent fillet welds easier. So again, we have our size being 1/4 inch, and then our length. We'll just go ahead and say our length is 2 inches. So that means it's 2 inches worth of weld, right? And then our pitch is going to be the distance in between them. So we'll call this 4. Now this isn't from, if this was the end of the weld, it's not 4 inches from end of weld to the start of the next weld. It is, we have our weld here and a weld here. It is 4 inches from center to center of each weld, not end to end. Let's do a little bit of practice on laying that out. We know we're going to start at the end of this fillet weld and do a 2 inch long fillet weld. Okay, we know it's 2, the pitch is 4. So from center of this weld to the center of the next weld is going to be 4 inches. So we count 1 to 2 is 1, 2, 3, 4. So 5 inches is going to be the center of my next weld. Now I know again that this is a length of 2 inches, so I'm going to go 1 inch to the left and 1 inch to the right. From 4 to 6 inches is going to be my weld. So now we have our weld spacing. We have a 2 inch weld here and another 2 inch weld here, 4 inches center to center, and we will continue this along all the way down this fillet weld. Now there's still one last thing to consider. Again, with the 1/4 inch sized weld, 2 inches long, 4 inches center to center as far as our intermittent fillet welds. If we do have intermittent fillet welds and we have that weld symbol on both sides, obviously we're going to be doing the exact same thing on both sides of the T-joint. Now there is such thing as a staggered intermittent weld where this symbol is going to be a little offset from the other. Now all that means is we're going to stagger it. So on one side we have our weld starting here on that first 2 inches, and on the other side we have it on staggered. So basically on this side there's no weld right here, but there is on this side, and it's just staggered all the way down. The welds are in different locations, but it ends up making a weld all the way down this fillet weld, either on one side or the other, but staggered intermittent fillet welds. And that's the last thing we'll cover. Let's get into measuring these things. So here's a better look of what that weld symbol will actually represent for the intermittent fillet welds. Okay, you can see that we've got them, almost 4 of them right here. If we go to the other side, we've got the other 3. All 2 inches long, they're staggered, all that good stuff. Now you just kind of count in your head about how long it takes to do that. Then you can actually set up your timer, and it's a lot easier to make these all the same length. You got to make some really clear marks so that you don't pass them up. Now let's get into these fillet weld gauges and how we actually measure all these fillet welds. This little dog here, this thin little piece of metal, this is your fillet weld gauge. They're actually really easy to use, really easy to find. You can get them on Amazon. You pick them up at your local weld supply. I got them at Outlaw Leather Weld Supply over here in Pasadena, Texas. And they come in a variety of shapes, or basically sizes for different size fillet welds. You never know when you're gonna have to put a big old dog on there as far as a 1 inch tall fillet weld. So let's go into what these weld sizes look like with single passes, and then how big they get as we start putting multiple V passes on there and how we can control it. These fillet weld gauges are really easy to use. All you do is set it down flat on the plate and you bump it up against the next plate. That's how big a 1 inch fillet weld looks like. Now on our weld coupon, or our weld symbol, excuse me, we had a 1/4 inch that we were shooting for. So we gotta find our 1/4 inch sized fillet weld right here. You can see that right there, 1/4 inch. So that's our fillet weld gauge for a 1/4 inch. We set it flat, not any hunky-dories this way or that way, and then we just bump it up against the side. Let's get a lot closer so we can tell. Now that we're up close and personal, we can see this a lot better. Get close. We want to see the top of that, the toe of this weld right here, that top edge needs to basically hit it. Now, if you're being picky, that's not a 1/4 inch. That's an undersized fillet weld. That's not a 1/4 inch. That's closer to, let's find it. Let's find it. What's under a 1/4 inch, everybody? 3/16, Austin. Yes, indeedy. We got to find the fillet weld gauge that says 3/16. Here we go. 3/16 is right under that 1/4 inch. Boom. You see how that fillet weld gauge wants to kind of, it hits, man, right at the top of that toe. It touches it. We want it to touch. Okay, there is a little bit of a wobble in this, and that's probably my fault with the fit up, but that's an undersized fillet weld. Now, one thing to keep in mind as you're welding these is there is a tolerance, okay? We are a 32nd away from being right on the chili with the size of the weld. So we are sort of in tolerance from what we can have, depending on the code that we're welding to. Now, if this is an undersized weld and it needs to be bigger, there's only one way to fix that. Let's grind them off and just go a touch slower. Sucks. But that's the way you're gonna have to do it if it's out of tolerance. We're looking at a 3/16 inch weld, all these sides of this intermittent fillet weld. I would say it's probably good. A 1/4 inch plate is what we're welded on, so it's pretty much right within the max needed size of a weld on this plate. But let's look at all the other welds that we did today as far as the smaller rods with 7018, 6010, and the other MIG weld that's a little bit bigger. Let's take our first look at the 3/32 7018 and take our 3/16 inch fillet weld gauge. Boom. That 332 is pretty much a 3/16. And if we want to get a little closer to really see that. Beep, 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 beep. Come on. 3/16, right on the chili, right? It might be just a hair because of that plate, but then we can take our 1/4 inch gauge, which is going to be the next one up, right? And we're clearly over top of that weld toe. So we're at a 3/16-ish, mostly, for both sides of this fillet weld. That's a 1/4 inch. That's going to be our 3/16. So we've got a 332 rod, one pass, full rod is about a 3/16 inch size weld. Could work on some consistency. Now here we've got the 1/8 size fillet weld, which is good. It looks a lot like the 332, and if I take this 3/16 fillet weld gauge, it's pretty much the same. Now, this is a problem. You see we've got a little undercut here, and there is a smidge of it elsewhere. It's telling me I actually ran this rod too fast. So we slowed it down a little bit to get less undercut, and now we're definitely bigger than 3/16. This is just a good example. Now this is closer to 5/8 right here, or excuse me, 1/4 inch, closer to 1/4 inch. But see how the size is different all the way? Like this is a little bit bigger than a 1/4 inch right here. This is closer to a 1/4 inch, but this is a little bigger. That inspector might get a little picky and want you to bump that down, grind it down a little bit to make it that 1/4 inch size weld. But all we had to do on this 1/8 rod is just slow down to get a bigger weld. You can manipulate these rods to get the size fillet weld you're looking for. Here we've got our single pass with a 6010. I bet you it's a 3/16 size. Boom. You get to look at them enough, you start to kind of pick up on things. Yes, I see the undercut, but that's not what we're measuring. We're measuring that 3/16. I would need to fix this undercut by either turning something down as far as the machine or the arc force, or maybe I slow down on each of these whips to fill things in. It might be just because we were on the root pass. But both sides of these got some considerable amount of undercut, which is no good. But 1/4 inch, too big, 3/16, looks like the size fillet weld we're rocking with the single pass 6010. Last but not least, the MIG welding. This is our 3/8 plate. We got our MIG weld on here. We come across with this 3/16 gauge, and we are hitting that toe. We're hitting that weld a little bit. Okay, so it definitely is a little bit bigger. Go to that 1/4 inch gauge. We're looking at more of a 1/4 inch size weld. We flip it over. This is going to be the push side, I believe. Basically the one with more spatter. You see that this side has a little less spatter on it. We pulled this weld and we pushed this weld. Now this should be a wider and flatter weld. Little bit wider, a little bit bigger. I wouldn't say too much bigger. We can, again, go up in fillet weld size. This is a 5/16 fillet weld gauge. And I'm looking at that and I'm thinking, you know what? This might be closer to a 5/16 size weld on this here push side. On the back side, that pull, we're definitely smaller. So you can manipulate the size. MIG, I think, is a little easier to fix your size weld. That should get you a better idea of at least what each single pass can be. Now you've got to understand that you can change it. A 332/70/18 may get you that 3/16 size weld most of the time, but you can get it to get that 1/4 inch size weld if you just slow down a little bit. So there are other ways that you can change and manipulate it. I think MIG is probably the easiest to kind of control how much fillet weld and easiest to size up it, or I think that's what I'm getting at. But how do you get to a 1 inch size fillet weld? You make multiple passes. So the MIG's already set up on the AHP machine. We're gonna keep running this old dog and see how big these fillet welds get after each layer. Well, let's see what 2 beads looks like trying to run that same pull motion with MIG, same bolts, same wire feed speed, same everything, same patterns. We're just gonna put 2. Here's our 2 bead pass. Tons of spatter on here. Probably need to change up my inductance, but we're gonna go ahead and use the 3/8 sized fillet weld gauge. And man, that's a 3/8 size weld if I've ever seen one. And you gotta come around and you gotta hit every single piece. If there's one spot, like over here, if it's a little lower than 3/8, you've got an inconsistent weld size. That's why it's so important to keep things consistent. But this is a 3/8 size weld. And as we learned, if we're welding on 3/8 thick plate, this is the max thickness that I really need as far as fillet welds. I don't need to put any more on it. If I did, it'd just kind of be extra. Well, let's go ahead and be extra. Let's throw down 3 welds. I'm gonna run this way so I can see better. Sheesh, that's a hunk of weld. Now all this spatter and stuff is definitely undesirable, and we're at that weird range as far as MIG welding and the globular transfer. You're gonna have a lot of that spatter, but we went from 3/8, this is a 5/8 size. We're putting that right up against it, and we're at about 5/8 of an inch as far as this fillet weld goes. So let's try to let's see what happens. So far it went from 3/16, then we went to 3/8. So we almost doubled in size there. So we doubled in size on the first one, then to 5/8. So we've gotten a little bit bigger. It didn't quite double. Let's do what your instructor's probably telling you in school. Do another layer. 1, 2, 3, 4. It's not super uncommon for you to get a grinder, all that BBs and buckshot, and maybe we have some uneven spots. You can, in a lot of places, take a grinder and just simply bump those toes, clean up your plate, and clean up your weld a little bit and shape it. That's what we call it. All right. Now we've got ourselves a 3/4 inch size weld. We still haven't made it quite to an inch, and I think we'll probably stop right there. And you can also tell we're doing a lot of welding on one side, and the distortion's pulling that one piece over because of all the welding that we're gonna be doing. So you really gotta take that in consideration. This is not gonna give the best reading on a fillet weld gauge. You can still kind of tell, but we're not gonna be able to hit square as we've come across it. Also, all that BBs and buckshot you need to be conscious of, because if you leave these fillet weld gauges by your piece, you're gonna get a bunch of buggers on them. Now I still got that other side with a single pass, a root pass in it with MIG. I'm really curious to see if I turn this old AHP all the way up to see what size fillet weld we can accomplish. So let's give her the beans. 26 volts, 600 on that wire feed speed. Let's spray one on. Sheesh, look at it go. Jeez, that was crispy right there. And we take this is a 1/2 inch fillet weld gauge. You can see the booger that I left on it. That's from leaving it out. But we got a whole 1/2 inch. Now we went ahead and skipped that 3/8. We went ahead and got all the way to 1/2 inch weld size with just a single pass. Now the biggest takeaway from this, guys, is just understanding while you're in school and while you're learning that this is what your instructors are preparing you for. Sure, they're having you put another layer on, another layer on, another layer on. That is to get the fundamentals of the welding process down. But as far as the fundamentals of a fillet weld and the weld symbols, I hope this helped you better understand the why you do it the way you do it. Shout out to AHP for this Alpha MIG 231. It was a beast. It hang tight. We welded just about everything to kind of get an understanding of fillet weld size. And again, you can adjust your wire feed speed, your volts, your amperage, your travel speed, all these things to control that fillet weld size. You've got to know this stuff, guys. Thanks for watching. If you've got any questions, go to that Weld app, get in there, ask them. If I don't get to them, someone else will. Thanks for watching, everyone. We'll see you on the next one.